In question number 35, each of the resistance shown has a resistance of 10 ohm. This is all 10 ohm, and each of the batteries have an EMF of 10 volt. 10 volt this, 10 volt this, 10 volt. Find the currents to the resistors A, and to the resistor B. This A, this B in these two circuits. So let's go through this. Let's draw this circuit again. We have these two batteries, resistance A, and then this is resistance B. This is 10 volt, 10 volt, 10 ohm, and 10 ohm. So let's label it maybe 1, 2, 3, 4, 5, 6. Just to 6, maybe 7. Just to find a node at which loop we are working it. We can apply the Kirchhoff voltage law in this loop 1, 2, 7, 6. I write it 1, 2, 7, 6. On the right hand side, I write the battery voltage 10 volt. And let's say the current is flowing in this direction. So this battery supplies this current, and in this room resistor it gets the IR voltage drop is, let's say the current is IR in this resistance IA. So I write it IA into R 10 ohm. That means IA is equal to 10 divided by 10 or 1 amp. So that solves our first problem. For the second problem, we take this loop 2, 3, 4, 5, 6, 7, 2. 2, 3, 2, 3, 4, 5, 6. So we get 2, 3, 6, 7, 2. So this is the battery 10 volt supplying the current in this direction. So we write it 10 volt here, and that will be equal to the current supplied, the current drop, IR drop in this resistor, that will be equal to 10 ohm multiplied by 1. And then let's say the current flows in this direction, and that current I call it in this direction and I call it IB, then plus 10 ohm multiplied by IB. IB is the one that we need to find out. Now 10 gets cancelled, so we get IB is equal to 0 amps. There is no current flowing in this resistance. In part B, let's go back to this circuit, the second one. In the second one, we will use a little trick. The trick is, if this is the 10 volt, this is 10 volt, this is 10 ohm, this is 10 ohm, then look at this resistor and the voltage on this point and this point. This point, see rest of the circuit exactly the same way as this point. It means these 2 points are in symmetry. And there is symmetry because the resistances are equal, because these 2 voltages are equal. What it means that the current in this resistor B is 0. So I am going to simply write IB for second part. IB is equal to 0 by symmetry. In the exam, you will need to write some explanation the way I explained. So that reduces the circuit to very simple circuit, something like this. This voltage, this resistor, and then this resistor, and then this battery. Now we can apply Kirchhoff voltage law in this loop, and both loops are same. So this is 10 volt, this is 10 ohm. So the current in this resistor, we don't need to find the current in this resistor, C. So this current I will be equal to V by R, or 10 volt divided by 10 equal to 1 amp.